Okay, so let's look at combinations. Now, for combinations, the key thing to keep in mind is that order is not important. I'm underlining these things, which means this sentence is important. All right, anyway. So, let us say that you have 12 candies, all different and unique, in a bag. And you're going to reach in and grab 5 random candies. So think back to your Halloween days as a kid, and we're going to look and see what is the number of combinations you could get of these 5 candies out of a possible 12. All right? Order does not make a difference for these. We're just concerned with which different groups can I make. So we're going to stick with our conventions of naming the total number of items. Okay, so n is our number of total items. So in that case, that is 12. So 12 is our n. And we're going to have r again. R is just our number of items grouped. Okay, kind of like what we saw with permutations when we were only selecting some. But this would make 5 our r. Again, your r has always got to be less than or equal to n. N is always greater than or equal to r. All right? So putting these into the formula, we're going to have it look like, our formula look like this. N factorial over the quantity n minus r factorial times r factorial. Be very careful when you're putting these into your calculator, when you're using these. You always need to do this n minus r quantity first, and then do your whole denominator before you do your dividing here. You can use your calculator with parentheses to separate these. You can just do them separately and keep track of them. Just be careful, because it's really easy if you're just punching stuff into a calculator to get this tripped up. I'll give you the correct answer at the end so that you can confirm that you're doing it correctly. So now that we've got our formula here, all we have to do is plug in. We said that our n is 12, so we're going to have 12 factorial over 5 is our r. So down here, this is just 12 minus 5 factorial times, we're just putting r in directly, that's 5 factorial. And we can simplify this to be 12 factorial over 7 factorial times 5 factorial. Okay. So again, be careful when you are calculating this. You can do these individually, multiply them by each other, but our end result here should be 792. Okay, and if you were to look at the permutations of just 5 of these items out of the 12, you're going to get a number that's much bigger. Combinations tend to be smaller, or the number is much of a lower value than if you were to look at the permutations, because the order, not having that order in there gives you many fewer options. All right, but this is our combination formula. Plug it in as so. Make sure to take care when you are calculating the denominator. Make sure to do that before you divide. Do all that together before you divide from your numerator. And remember, the combinations order is not important. That's the key difference. Okay, and you've got All the items here really are the same. They can mix and match. The key thing when you're looking at permutations or combinations is you need to know what you're looking for. Once you know what you're looking for, what you've got, then you know what to use. If you know that order is going to be a factor, well, then you should think of a permutation. If you know that you're dealing with different things, then think of the fundamental counting rule, and think of your combinations of clothes for outfits, or appetizers, entrees, and desserts, however you like. If you can identify which one you're going to use, the formulas aren't that bad, and then you'll be able to determine what you're looking for with relative ease. You've got the formulas. They are pretty simple once you can identify your N and your R and whatnot. But you just need to know which one you're going to use. That's really the challenge of these problems. All right, good luck with it. Let me know if you have questions, and have a wonderful day.